Hello YouTube, Xcity here. In this video we are going to solve Binary Heaven, which is a room on TryHackMe. It starts off with some light reversing and debugging, and we then exploit a simple stack overflow followed by some path hijacking on a set UID binary. So essentially, if you start with the room, you get the IP of the box, but you don't have any credentials to log in, and there's basically only SSH. So in addition, they give you two binaries. There's this angel_a and angel_b. And one of them will give you the username and the other one the password. So let's actually start with the Angel A1, just running a quick strings here. And we already get some idea here. Seems to be some kind of debugging protection because we see some string mentioned here with a link to YouTube. It wants us to enter a username, and it will basically tell us whether it's correct or not. So this is a typical crack me kind of challenge. And let's try to actually debug it. It's going to run it, and here we get this anti-debugging message. So we can't do that without going through some additional steps. And the way I approach this, I'm going to use Angr to solve it because it's really easy. So let's actually look at the script. I already wrote it here because basically that's a template I always use for these easy challenges. And what we're doing is just loading the project, defining an entry state, instantiating the simulation manager, and then we run it. And what it is doing, it's basically using symbolic execution to explore all possible paths throughout the program. And then there's a bunch of terminated states because they all lead to exit eventually. And we are going to loop through all these states and print out the input that led to these states. This works very well on smaller binaries, small crack me challenges. On bigger ones, it's a bit problematic because it needs to emulate a lot of stuff and things can break. But for small things, it's really, really good. So let's actually switch to my environment for Angr. Then we're going to run it. And it's already done and found the username here. So that one was pretty easy. So let's look at the second one here. Going to run strings again. And this time we can already see these are the typical strings you find in a Golang program. So this is a Go program. And if we go through all of these, there isn't really a password here. So we have to dig a bit deeper here. So let's try to run it in debugger again. And this time it seems to work. There don't seem to be any anti-debugging measures. So let's just enter something here. And obviously this is the wrong magic word or password, so we don't get very far here. Let's actually make it a bit bigger, and I'm going to have a look at the main method. So let's break on main first, run it, then we're going to disassemble it. And even though this is Go, it's pretty readable. Just some output here. There's a mem equal here, so this is interesting. This is probably a comparison for our password. And if we look up a bit more, there's F scanline, which essentially reads our user input. And we can see that the length is compared with B. So we have to enter 11 characters. And if we do that, it will eventually be compared to something down here. So let's make a breakpoint here. Let's run it again. Continue, and this time we're going to just enter 11 characters. And now we are at a breakpoint on the mem equal, and here we can already see what it's comparing our input to. It's this password here. And actually it's not quite complete here, so we have to inspect the address manually. Here we can see that we are missing an exclamation mark. So this is our password. And now we should be able to SSH into the box. And this has worked. So now if we look at the home folder, we have this setUID binary here. And there's this user binxgod, which we probably become if we own this binary. There's also this Python history here, which already indicates that it's sending a bunch of A's. So this will be a binary exploitation. And also we can read the Guardian flag here, right? Not going to do that now, but yeah. So let's actually look at the binary. Let's copy it to our local box, just using SCP here. And we're also going to copy the libc and also this one. So we all got them in this folder here now. And we're going to start off with an LDD on the binary. And since we copied it, it will now try to use the libraries from our system instead one from the box. So we have to fix that. So what I'm going to do is I'm going to use patch-elf to tell it to use the local libraries. And we can run it now. And if we look at LDD, we see that libc for local directory is used. So let's approach this. I prepared a skeleton here, and this is basically always the same with some minor modifications. And all this is doing is basically loading the binary, loading the libc, and we prepare a switch that if we give it the argument SSH, it will SSH into the remote target and execute it there. And if we don't give that argument, it will execute it locally. And there's no export or anything yet. This is just so we can interact with the binary. And if I'm running this, we just execute it. And it's just basically a wrapper, right? And if I do the same thing with the SSH argument, we're going to run it on the remote end. So this is just for convenience. Now let's start to actually do something here with the binary. If we just run it, there's basically this line of input we want to skip, and then there's a system leak from libc here to make it a bit easier for us, so we don't have to worry about RSLR too much. And basically what we want to do is we want to parse this value. So let's do that. First of all, this eats the first line of input. We don't want that. And then we are going to extract the value from the line. Going to take the input from -11 to the end, which is basically, if you count, it's this piece here. And then we are going to strip away the new line at the end. And right now this is a string, so let's convert it to an integer. And we use this index 2 here because it starts with 0x, and we don't want that in the integer conversion. So let's log that out. And also, now that we have this address, we want to make it so Pwn tools will actually take that into account when we want to take symbols from libc. So we're basically telling it now where the load address of libc is based on this leak. So let's run that, see if our leak code is working as expected. And this looks good. Here we have the address and the output. So now that we have this leak, we actually have to think about what we want to send. So let's make a buffer, send a bunch of A's, and then actually send the buffer. And let's see what happens now. Before we actually send this, we want to attach GDB. And in Pwn tools, we can do it like that. So that basically automatically a debugger will be attached and opened when we run the script. So we can actually see what happens. So now we got a crash as expected, really, because we saw earlier it will probably be 32 characters, but let's confirm this. We got a crash at AAA, so this is working as expected. Let's actually generate a pattern here. Let's send this pattern. Now we got a crash at this address, and we can use pattern offset to find the exact offset. And here we can see that the offset is 32, as we already saw in the Python script, but now we confirmed it manually. So now the next B's will basically be put into the instruction pointer. Let's confirm that. And this works as expected. Our bees ended up in the instruction pointer. Now we just have to think about the actual payload. And from the leak, we already get the address of the system function. So it's probably a good idea to just call system with an argument of bin_sh to get a shell. So let's do exactly that. Instead of the bees, we are just going to send from libc system. This is exactly the address we got leaked. Basically, you could also directly use this leak address here. But since we readjusted the load address of libc in this line, we can also call it like this. And the only argument we need is bin_sh, but the bin_sh string has to be at a place where we know the address. And you can also in PwnTools just tell it to search for the string in the libc that is loaded, and it will give us the address here. So this is basically all we really have to do. And remember that on 32-bit systems, arguments will be passed on the stack. So the first argument will be a pointer to this bin_sh string. And that's basically all we have to do. So let's run this. And here in the debugger, we can see that user bin dash was spawned. So this is working. And we got a command shell here. All right. So let's remove this GDB line and run it with the SSH command line argument. And now we got a shell on the remote end as bin_xcod. So let's actually switch to his home folder. And here there's another flag. And other than that, there's also a new setuid binary, which is this val binary, which has setuid and an owner of root. So this will give us root on the box. So let's look at the last part. Here we actually get the source code. So there's this val.c file. Let's have a look at that one. And we can see that it's basically executing a system command, which is echo of some string, and it's not using the full path for echo. So if we were to place our own version of echo in the local directory and then add the local directory to the path, it would execute our script instead. So we can use that to escalate privileges. Let's just create a really simple shell script here. And this is something I always do. Basically, we're just going to give the setuid bit to bash. So when this runs, we can afterwards just use bash -p to get the root shell. Now we have to include the local directory in the path. Then just run the binary. And we can see that it worked. There's the setuid bit now on bash. So if we let's run bash -p, we become root. And here's the final flag, the root.txt. And this is basically it for this room. Thank you for watching and see you next time.